Welcome to another important concept in trigonometry. We'll talk about cofunction identity and its application in this particular video. We are going to solve two questions, rather evaluate their value without calculator. You can always join my classes by sending an email on the address given. Enjoy the journey of success. Now, let us see, how do we solve such questions, rather evaluate such expressions? I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up cofunction identities. In case you want to learn from me, you can always send an email on the address given here. The question here is, use the cofunction identity to evaluate the expressions without calculator. Question number 1. Sin x, sine of 90 minus x over tan x plus cos x, cos of 90 minus x over cot x. You need to evaluate the given expression. Question number 2. Cos squared 22 degrees plus cos squared 68 degrees divided by sine squared 18 degrees plus sine squared 72 degrees. You can always pause the video, answer the question, and then look into my suggestions. Let's try to understand what is a cofunction identity before getting into the solution of this particular question. Here is a triangle. Let us say one of the angles of the triangle is theta. I am taking a right angle triangle. In that case, the other angle will be what? This angle is going to be 90 degrees minus theta. If the sides of triangles are A, B, and C, in that case, what is sine theta? Sine theta will be side opposite, which is B over C, right? So sine theta is B over C. Now see what is cos of 90 minus theta. When you see from the other angle, which is 90 minus theta, the adjacent side now is B, which was the opposite to theta. So that is also B over C. So what you notice here is cos 90 minus theta is actually equal to sine theta, correct? So we come to an identity which is cos of 90 degrees minus theta is equal to sine theta. Similarly, you can show that sine of 90 minus theta will be cosine theta, and this is what we call cofunction identity. So now I hope it is absolutely clear. You can pause the video, answer the question, and then look into my suggestions. So let's begin with the solution of the very first one. Now let us look into the solution of question number 1. We are given sin x, sine of 90 minus x divided by tan x plus cos x, cos of 90 minus x divided by cotangent x. We can write this expression as equal to sin x, and what is sine of 90 minus x? It is equal to cosine x, right? Using the cofunction identity, over tan x, tan is sine x over cos x, plus cos x, cos of 90 minus x is sine x over cotangent x, which is cos x over sine x. Perfect. Now, we can actually take cos on the numerator, sine remain in the denominator. So let me rewrite this particular statement as, so I'm not cancelling at present, but I'm trying to add one more step so that it becomes absolutely clear how this sine and cosine look like. So sine remains in the denominator, right? And this cos x goes into the numerator. Perfect. So the second term will be now cos x times sine x over cos x. Clearly you can see that sin x and sin x cancels in the first term, cos and cos in the second. And what are we left with? We are left with cos square x plus sin square x. Clear? And that is indeed equal to 1 using the Pythagorean identity. So this is an application of Pythagorean identity and cofunction identity. Correct? Now let's look into the solution of the second question, which is cos square 22 degrees plus cos square 68 degrees divided by sin square 18 degrees plus sin square 72 degrees. Well, you notice that 22 plus 68 is 90. Perfect. And therefore, I could write 22 as 90 minus 68, right? And therefore, I'm going to rewrite this equation as cos square, and instead of 22, we are writing 90 degrees minus 68 degrees. That is 22 degrees, correct? Plus cos square 68 degrees divided by sin square 18. 18 plus 72 is also 90, right? Do you see that? So let's write down a note here. What we note here is that 22 plus 68 is 90 degrees, and also 18 degrees plus 72 is 90 degrees. And therefore, we can use the cofunction identity, right? So the denominator now becomes sin square 90 minus 72 degrees plus sin square 72 degrees. So cos square 90 minus 68 is becoming sin square 68, correct? So I could write this as sin square 68 degrees. And we already have cos square 68 degrees in the numerator. Denominator now becomes this becomes sin 90 minus 72 is cosine. So we get cos square 72 degrees plus sin square 72 degrees. In the numerator, as you can see, we have sin square x plus cos square x, which is 1, and denominator is also 1, and therefore this expression is equal to 1. So that is how we can actually evaluate the expression without calculator. So I hope the calculations are understood. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. If you want to learn from me, you can send an email on the address given. Thanks for your time and all the best.